For demonstration 3, I gave the cart a push and allowed it to travel towards the 0 point before coming to a stop. Now we're not talking about the part where it's actually pushed, we're only talking about the part after the push, when it's in motion until the stopping point. So I know that the cart is traveling, it's moving already. So I know I'm going to start with some initial velocity. The question is it positive or negative? Well, remember, if I'm traveling back towards 0 from a positive position, if I have a positive position and then travel back towards 0, then I'm moving in the negative direction. So that means that I have to start with some negative velocity. And since I stopped, I know that at some time later on, my velocity is going to be 0. So there's my velocity versus time graph. Now with that being the case, remember as I'm going from a velocity versus time graph to an acceleration versus time graph, all I'm looking at is the slope. So it doesn't matter that all of my velocities are negative because my slope is positive. So then my acceleration is positive. Now if I were to think about what my forces look like, again, I should look at my free body diagram. So I'll draw my picture. So here I have my picture. In this case, here's my cart. Here's my string. The velocity is this way this time. So then when I draw my free body diagram for this, I'm going to say, okay, I have a force from the earth on the cart. I have a force from the track on the cart holding it up, and those two are going to cancel one another out. The string is pulling the cart this way. And I told you that there aren't any forces opposing the motion of the cart from the track. So there's all my agents. So those are all of my forces. So then this means that the force that's applied, my net force, is again the force from the string on the cart. Awesome. So then since that's my only force, then that's the force that's causing my acceleration. So then when I draw this, it's constant. Just like that.